acceleration vector is t 0 e to the negative t, right? Now we have to find, so if the acceleration is like this, so for example, if you are applying a force, okay, of this type, all right, and you have the other things known, then how would you find the path of this particle, right? Okay, so acceleration, you know, is what? The derivative of the velocity, okay? And interrupt, okay? I'm not going to ask on your name because we are being recorded. I mean, but you feel free to ask me a question if you want. So how would we get my V? We will go ahead and do what? Any three of you, just give me a suggestion. How would I get
Take
my
the
V?
integral.
Louder?
The
Take the
derivative.
integral.
Okay, very
Integral.
nice. Yeah, take the integral, right? So the first component would be, say, this, right? And the second one would be what? That will just be a constant, right? Okay. And the third one would be negative e to the negative t. Are we good on this? Okay. Now, how do we obtain these guys, a, b, and negative e to the t and plus c? How do we obtain our a, b, and c?
They're
Anybody?
constants because we integrated.
Right. So we are given an initial condition here, right? That v at 0 is what? 0, 0, 1. Isn't that given here? So what you can do is just substitute t equals 0 in here. So what do you obtain? You obtain t becomes 0, then this is a. Then here I have b, right? E to the negative 0 is how much? That's simply a 1 plus c, right? So what does it give us about a, b, and c now? Uh-huh. A is how much? Just compare these two. Just please talk to me.
A is 0.
0, B is 0.
0.
Yeah, and C minus 1 is 1, right?
Right. Which
C,
means C is 2.
C will be 2, right? So our V is going to be, we'll just substitute these values of A, B, and C. But at the same time, we know that V is who? dr dt, right? Are we good? Okay, so this shows us that dr dt is going to be t square over 2 and a is 0. So we are just going to leave it and b is 0. That's what we found, right? And c is 2. So this becomes negative e to the negative t plus 2, right? Are we good? Now lead me to R, please. What R is going to be? Please, anybody, help.
T cube over 6.
Very nice. Plus a constant. I'm just writing a big A here. Here we used a small a. And 0, we will just have a big B here, right? And for this one, the antiderivative of negative e to the negative t would be e to the negative t simply. And then we have 2t, right? Because of this. And then plus a big constant c, right? Okay. And
Sorry,
since,
what is at the end here?
louder.
What is at the end after the B? I can't really tell.
Oh, after the, let me write that again. I'm sorry. Come, okay, here. Okay. Oh, this part you mean, right?
Yeah.
Okay, let me just write it a little more clearly. No, why? Okay, that's not erasing it because I wrote that by this pencil. Okay, so one moment, I'll write it for you. Okay. That's all right, sorry. Okay, it's okay, don't worry about it. Let me write it again for you. Okay, so here, the antiderivative of this is going to become e to the negative t. Am I clear on that?
Okay, that's good.
Okay, and then for 2, it will be 2t, right? When we are integrating it, right?
Yeah.
And then at the end, we will have a what? And then at the end, we will have a constant of integration, right? That is c. Okay. Now, help me with big A, big B, B, big C, because you know that R at 0 is 0, 0, 0,
Zero.
right? And if we substitute those guys in there, what do we get?
Zero for A, and then it's
Ve-
E to the
ve-
number 6,
Yeah,
and
0 for
then
B also, right? And yeah, keep talking.
0 for C.
No, so here we will get a 1, right?
Oh,
Yeah, and this will become a 0, and this would be a C, right? So if this is 0, then C will be negative
Negative
1,
one. Right.
and all these guys are 0, right? That be good?
and you got that by saying 1 plus C just equals 0?
Yes, exactly, because 1 plus C equals 0. So C is negative 1. Okay. All right. Sorry, my pen dropped. So let me do this here. Let me pause the recording and then go over